I'm here on a lovely sunny day on the banks of a river in South Wales in the United Kingdom. Now this particular river has just been in flood in the last week or so. We had heavy rainfalls coupled with melting of quite a bit of snow that we had the previous week. Now you can see that the water is quite muddy with silt and clay in suspension. Now during the flood, a lot of that water would obviously have come up the bank and overtopped onto the floodplains. And you can see just along here that some of that silt and sand, fine sand, has come out of suspension and been deposited on top of the vegetation of what was otherwise quite an erosive bank. And if we look here, we can also see some evidence of erosion during the flood as well. There are cracks in the bank here where sections of the bank are coming away. And so indeed one small section has indeed come away just over there. And you can also see that the vegetation on the bank has been laid flat by the flood and the high velocity, or relatively high velocity waters flowing across them. So that's a recent flood, but I really wanted to come here to show the geomorphology of a typical river, where we have the channel flowing, with the water flowing within it here, coming through at a fair pace at the moment. And then of course we have the bank itself, and this bank is a mixture really of an erosional bank because it's quite cliffed, but on the river side of the bank it's been there's new deposition starting to build up and vegetation taking hold, so it's trying to repair that erosion, and we can see that with the new deposition from the floodplain, from the floods this week, just building up there in front of those erosional cliffs. But as we come away from the bank, further inland, we can start to see that on top of the bank we have here a relatively raised section of the landscape here. It may not look it particularly, but it is raised, and we can show you how in a minute. And this is actually the levee of the river, and this is formed when the floodwaters come over the bank of the river during flood, and because of the friction of this vegetation that you can see, this grass acting on the floodwaters, it slows the floodwaters down as soon as they come out of the river channel, and it helps to deposit sediment. It encourages the deposition of sediment right here next to the river channel, and that's how levees build up, because they are the focus for a lot of the deposition of flood-derived sediments. And as we move off the levee and walk away, sort of right angles to the river channel, across the floodplain, we can start to see that we have the remnants of the floodwater remaining on the floodplain. Now the reason why we have floodwater here and not behind me on the levee is of course because the levee is raised, because we get preferential deposition there as the floodwaters come out of the channel and deposit their load. And as you come away from the channel, deposition becomes less and less. So in fact we have a slope that comes from the levee inland across the floodplain and away from the channel. So it actually gets lower and lower until of course you get to the sides of the river valley, where you've got slope processes bringing sediment down off what is a ridge on the other side of the river valley there, and sediment is coming down there to be deposited at the base of that escarpment. So we have this wet area at the moment, which is the remnants of the floodwaters, and they're pooling here because the levee is higher. And of course this water is trapped here. It won't be able to get back to the river channel except through seeping through the floodplain sediments, which of course are quite waterlogged at the moment, so that's going to be very difficult. So with bright sunshine like this, and perhaps with a few breezes, this water will start to evaporate. And of course it will be replenished if we have any more rain, and so it might be quite some time before this floodplain actually dries out again. So at the moment then, these sediments on the floodplain are waterlogged. If we had a permanent waterlogging situation like this, then the soil would actually not be able to break down organic matter, and we might start to see a floodplain peat forming on the surface here, or organic soil which could turn into a peat. But I know this area quite well, and I'm pretty sure that this will start to dry out in the next few weeks or couple of months. And so air can start to get back into that soil and break down the organics, and we'll end up with a soil that's quite minerogenic, not much organics in it, and one that might have some mottling, which reflects soil processes that are typical in these floodplain environments. Now, this process of sediment coming out of the river and being deposited on the levees or on the banks, as we saw earlier, but also there is some sediment making it onto the floodplain. That's a process of alluviation. Fluvial sediments, that's river sediments, being deposited are what we call alluvial sediments. And so the process of alluviation actually builds up the floodplain to quite a thickness. And we can gauge the thickness of this particular floodplain by going back to the river channel. And you might be able to see quite clearly that the height of the banks against the river, which is still quite full of floodwater, is quite substantial. There's quite a thick sequence of alluvial sediments being built up by this river over thousands of years. It's probably since the last ice age. And indeed, we do have radiocarbon dates of peat deposits right at the base of this alluvial sequence, which date it to late Stone Age times, 7,000 or 8,000 years. So that's when this river started to lay down floodplain sediments. And of course, that is because that particular period of time was when sea level began to rise after the last ice age, and so waters flowing off the land would have started to meet an ever-encroaching coastline. That would have helped to impede the drainage of these fluvial river landscapes. And so the river essentially is being backed up, the river channels, and when you have a high rainfall event, high flood event, then that water does start to flood out of the channels, and that's when alluviation starts and floodplains begin to grow. So during the present interglacial, the Holocene, many of our floodplains are relatively new. They're only thousands of years old, not tens of thousands of years old. And so they're relatively recent landforms. But they can tell us an awful lot about the dynamics of climate change. In fact, their origin is due to global climate change and ice ages finishing and deglaciation, and then interglacial conditions, such as we see today, being dominant. So wonderful landscapes. The geomorphology is important to understand in interpreting them, but they are inherently linked to climate, both in their origin at the beginning and also their development through rainfall events, which controls the flooding, which controls the siltation and alluviation onto the floodplains, which leads to their growth and development.